Hello student, we are going to start this chapter magnetic effect of current. Okay, so here we'll first start what is magnetic field. So like electric field also we can define what is magnetic field. So you say, let's suppose you have a magnet. All around the magnet you can see there is a modified space you can find. Now in that space or in that region if you are keeping any magnetic substance, you can see that those magnetic substance, they are going to experience a force from this magnet. So that means you can see they can get what attracted towards this magnet. Okay, so this force of attraction you can feel for a certain reason. As this distance goes on increasing, if you are keeping this magnetic substance, you are taking it away from this, you will see that after some interval or you can say after some reason, you won't feel that force of attraction. So that means what? The space up to which you can feel this effect of this magnet, okay, or you can realize the effect of this magnet, that particular space is called as its what? Magnetic field. Okay, so this is what magnetic field is there. Now magnetic field, like electric field, magnetic field is also a vector quantity. So magnetic field is denoted by the sign V. So it is a vector, so that's a V vector. Now what is the unit with which it measures? So SI unit is what? That is Tesla. Tesla, or you can say this is Weber per meter square. Okay, so this is the unit which is used to measure this magnetic field. Okay. Now we'll go for Oersted's experiment. Now what is this experiment is about? Okay, so here Hans Oersted in 1820 he explained that if a conductor is carrying current, then all around this conductor a magnetic force, or you can say magnetic effect is produced, or magnetic field is produced all around that. And what is that is called as its magnetic effect of current. So through his experiment he confirmed it. That means when a current is flowing through a conductor, all around this conductor a field is produced, a magnetic field is produced. How he can show that? So if you look at, suppose he has taken a straight conductor with the proper arrangement. This is a cell connected, this is a key. Okay, so this is a circuit he has taken here. And this conductor, let's suppose AB is the conductor here, which is kept just over a magnetic needle. Okay, so this is the magnetic needle. Now, when he switch on this circuit, and once the current started moving from south to north, so we have seen that. So in that case, what he has observed that the north pole of this needle was getting deflected in a particular direction. Okay, so again when he changed the direction of this current, so when the direction of the current became from north to south, he observed that the direction of the deflection of this north pole is also getting altered. It is also become opposite. And third observation was there when that switch is off, that means no current is flowing through the circuit. That time this needle, so that means when there will be no current in the circuit, the needle will come back to its own original position or initial position. That means there will be no deflection will be there. So what was the conclusion he has drawn through his experiment? He has observed that when there was no current, so that time the needle was remain as it is in its initial position without any disturbance. But once he allowed the current to flow through this conductor, he observed that this magnetic needle gets deflected from its original position. So this magnetic needle being a magnet, how it is getting deflected? Why it is getting deflected? It can be only deflected if it will be under a magnetic field. And there is no chance, like there is no other magnetic fields we can find here. So that means only observation is there. Once the current is flowing, this deflection is produced. That means it indicates that when the current is flowing through this conductor AB, there is a field, magnetic field must be produced, and due to which this north pole of the needle is getting deflected. So this is the whole total thing is about. So that Oersted's experiment tells that this is the magnetic effect of current. So what is the meaning of this one? That means when the current is flowing through a conductor, that we can feel the magnetic effect, or you can say the magnetic field is produced. So this is what we are studying in this chapter. Okay, now here, in which direction the north pole of this needle will get deflect? To find that, or to determine that, there are two different rules are there. One rule is called as what? This is snow rule. Snow rule. So this is one of the rule to find out the direction in which the north pole of the needle will rotate, or it will get deflect. So you can see the snow. So here S stands for what? That is south. N stands for north. O stands for over. And W stands for what? West. Okay. Now look at how this rule is applicable in this case. Now let's take first the cardinal directions here. So as we have taken, this is north, this is south. So this will be your west, this will be your east. Okay. Now, so here you can see, as per the rule statement, it says what? When the current is flowing from south to north. Okay. So you can see that here the conductor is there and the current direction is from what? South to north. Okay. And the conductor is placed over the needle. O stands for the over. This is the needle. Over the needle the conductor is placed. In that case, the north pole of the needle will get deflected towards what? West. So that means here, once the current will flow from south to north, this north pole will get deflected towards the west direction. Okay, so this is how we can able to find out or determine in which direction this north pole will get deflected. Now, if I am changing the direction, so that means if the direction of the current will be from north to south and still that conductor is above this, so in that case the direction will be towards east. Similarly, when it is below, so in that case also similarly the direction will get changed. So that means this is the rule how to determine in which direction the north pole will get deflected. Similarly, there is another rule is there which is called as the Ampere swimming rule. Ampere's swimming rule. So Ampere swimming rule is somewhat same as your snow rule. Okay, so look at what is this Ampere swimming rule states here. It says that suppose you are swimming in the direction of the current flow. Okay, so this is suppose you are swimming like this and the needle is this one, this is south, this is north of the needle. Okay, so it says here the statement of this swimming rule is what? It says suppose you are swimming in the direction of the current. Okay, so you can see that you are swimming like this way, this is the direction of the current flow, and you are also swimming in the same direction. Okay, and your face is towards the needle. So that means while you are swimming, the needle is like this. So that means you can see here you are above the needle. So this is the same what in the snow rule we have applied. So in that case, it says if the current is entering through your feet, okay, and it is living through your head. So that means the current's direction, if you look at it, is this from south to north. It's the same type like in your snow rule. Okay, so according to that, this is your left hand, this is your right hand. So it says that in that case, like that, what happens here? The north pole of the needle will get deflected towards the left hand of yours. So exactly the same what we got in snow rule. Here the Ampere's rule is same, but the statement is little different. So this is how we can find out in which direction the north pole of the needle will get deflect while the current is passing through a conductor. Okay, so this is what the Oersted experiment, and here it all talks about what? How means the current carrying conductor is producing the magnetic field, and what is that called as your magnetic effect of current. Okay, so this is all about magnetic effect of current. Next we will go for how to find out the magnetic field due to different current occurring conductors in the next video.